Hey, welcome back. Today we're discussing problem number 1269, number of ways to stay in the same place after some steps. We are given two integers, steps and array length. We need to calculate the number of ways possible so that you will end up being at the same place where you started after taking the given number of steps. So we are given an array of length n and we need to take step at each place so that after n steps we end up being at the same place, right? Same given starting point. We will always start at the 0th index. So in this example, uh, so this is of array of length 2. So initially you'll start at this point. So after 3 steps, you should come back to this point. So we need to calculate the number of ways possible. So at each step, you can stay in this place only, or you can move towards right 1 step, or you can move towards left 1 step. So for this, the possible number of ways given as 4. Let's see how. So one possible way is at each step for all three, you'll stay at the same place. Stay. So stay, stay. So that if you don't move, then after 3 steps also, you'll end up at the same place. So that is one possible solution. And the second possible solution will be, you can move right side, move on right side here. So you have taken 1 step. So you need to take 2 steps more so that you can stay at the same place. So now you are still at the 1th index. You can move left, right? So this is the second possibility. And the third possibility will be move right side, move left side, and you can stay at the same place, right? So, and the fourth possibility will be first step, you will stay there only, and you will move right side, and you'll move left side. So these are the 4 possible ways so that you'll reach the same starting point after n steps. So, I mean, if you take any other possibility, when if you go right, if you go left, and if you go right, then you'll end up at this position, which is not the starting position. So similarly, you can take, you can move left, but it is going index out of bounds, so you cannot move a left side because you are at extreme starting of this position. So you can move right, you can stay, and I mean you cannot move right from this place because the maximum length is of 2 only. So you can stay there only. This is the third step. Still we end up at first index. This is not the answer we want. So we don't consider these cases. So similarly, we have I mean many states where we end up at 1th index. So those states we don't consider. So these are the only 4 states where you end up being at the 0th index after performing n steps. So if you observe this, so if you take the recursive formula for this, so this is a recursive solution. So if you observe, the formula will be, so at every time you need to reduce 1 step, right? So number of steps minus 1. So steps minus 1, and then you can move right, or you can stay there, or you can move left. So, so at every place you'll be having 3 possible ways, right? So yeah, when you reach, I mean when you're out of steps, when these steps equal to 0, when you have taken all the steps, and when you're at the index 0, this is when you got the answer, right? So this is where you will return 1 step. So this will be the base case that we will search for, and we will write this recursion. So let me write this pseudocode, and then So we will at start at index 0 and calculate for given steps, right? So we will call a recursive function, like we'll call helper function with 0th index and remaining steps as steps. So we need so right now we're at, I mean, anyhow the starting point is 0 only, and we need to take these many steps, right? So in this function, if so, let me write recursive formula first, and then we can uh, check for the base cases. So helper at from ith index, if you have to take n steps, the possibilities are three possibilities, right? Equal to helper at. So you can move forward and you can reduce the steps, plus the second possibility is you can move rightwards, and yeah, you'll need to reduce the steps. And the third possibility is you'll stay at the same place and you'll reduce the steps, right? So you need to add all these values. I mean, these are the three possible ways, and yeah, this should be our answer. So what is the base case? If we found the answer, if we have completed all the steps, and if steps equal to 0, right, and steps is equal to 0, and then I is equal to 0 also. I mean, I being the index that we are at. So then only we have achieved our target, right? Then we will return 1. So this is one way you can achieve this, right? So apart from this, if you go out of the bounds, I mean, if you go left side, if I is less than 0, then there is no answer. So we can return 0, right? So yeah, similarly, or if I is greater than or equal to length also, we will return the same. Right. So this is the so apart from this, so there is one more base case that we need, right? So if here we are reducing the steps, right? If steps are negative, if we have taken all the steps, if steps are less than 0, then also we need to return 0. So this will be the pseudocode, but see, since we are calling the same helper function, and there is a possibility of repetition, so we can memorize the states. So I'll explain it how we do it in the while writing code. So we can memorize the states so that we can reuse it without calculating again. So here, let me call helper function with, we are starting at 0th index, and we need to take these many steps with array of length, this one. So before that, there is one more thing. So here, if you see, the number of steps are in range 500, and array length is of 10 power 6. So let's say if we need to take 500 steps, and if the given length is 501, so I mean, if we go to 501, then we have already completed 500 steps. So there is no point going back, right? So at max, we can go is for, I mean, is to number of steps only. So even though if we have array of length, so let me annotate once. So let's say we have array of length 10, and we need to take steps 5. So even So yeah, even though we have array of length 10, if you see, if you take only right, you'll come till here. Then the steps will become 0. So you cannot go back from here also, right? So these you don't need to consider, because anyhow at max you can take number of steps only. So yeah, so we can update this array length at the starting itself, so that we don't need to consider the extra array that they have given, because it would be anyhow take so much space and add to our time complexity, right? So anyhow, we know that at max we can reach till this position only to be one of our answers. So yeah, so we will update this array length value to the minimum of, so array length will be math dot minimum of steps comma array length, right? So I hope you are clear on the steps why we have taken minimum of these two. So let us write this helper function. A function which will take the I index. Let me call it I only. Steps and array length. So the base case will be if I is less than 0, or or I is greater than or equal to error length, then we'll return 0. Right. So if the second one will be if steps are less than 0, then also can return 0, because we have already crossed the number of steps. If we found the answer, if we found one way, if we have reached the first index and number of steps are equal, so we can return 1. So now our answer will be, we will call this function helper function again, and right now we're at the same index, and let's decrease the number of steps. We have already taken one step, we are staying at the same place, and let's call this. And this is one possibility, and the second possibility will be answer plus helper of, we'll move right side, steps minus 1 array of none. So this is one possible answer, and also the last possibility is answer equal to answer plus helper of, we will move towards left side, and let's replace the steps. So these are the three possible states. So the question they have given that we need to take modulo, because the answer might be very high. So at every step, take mod. I'll define that mod. So this mod will be equal to the saying 10 power 9 plus 7 of 10 power 9 plus 7. So this will be it. We need to return the answer. So this is the recursive solution. Let me run this. Okay, there is where ln is not defined. So I'll use capital letter. Let me see where. Okay. So, I mean, here it should be and, right? We need to reach the first index, and steps also need to be 0. So, by mistake, I've written or. So, I guess that's the mistake that we have done. Yeah. So now, I mean, definitely it will not get accepted if we submit it, because in here we have so many repetitiveness. So let me show you. So initially we started at 0, comma, let's take n as 5, right? This number of steps is. So we will do same 0 and 4 and 1 and 4 and -1 and 4. So these are the 4 possible ways we'll call this recursion. And then from 0, 4, we will call 0, 3 or 1, 3 or -1 and 3. So here we will call 1, 3, 2, 3 or 0, 3 when you move left side. So if you see, there are so many repetitive calls that we are doing. 1, 3 also is getting repeated. So if we extend it further, there will be so many calls, right? This is the recursion tree. So this is the recursion tree. So yeah, if we solve this, so let us store it in some memorization so that we can reuse it further. So yeah, I mean, you'll understand this DP problems using memorization and DP once you solve it first through recursively, and then go doing it in memorization, and then apply DP. So here our memorization array, I mean, let me take it here. I'll take 2D array to store number of steps and length. So this will be our memorization. And let us initialize this. This dot memorization equal to new int of we need to take steps +1, because we need to reach till steps, and then array length. Why we have taken +1? Because we need to reach to that step, right? We should not add, I mean, if we take this only, we have an index of steps, right? So I equal to 0, I less. So I'm just giving some negative value, I mean, given -1 value, so that we'll identify which value we have calculated on. So I plus arrays dot fill memoization of I with -1. So fill all the arrays with -1. And here, if you have already calculated this value, if memoization at steps and I, if this is not equal to -1, then you have calculated this value earlier. So we can return memorization at steps. This one. So before returning, we will we will put this into our memorization matrix at ith index equal to our answer. And this answer. We quickly run this. There are any issues? No. Let's quickly submit. So yeah, so it got accepted, but I mean, the memory we can do better by using DP and like avoiding these recursions. So for DP, if we want to convert this memorization solution into DP, right? So what you need to do? So you understand here that we are returning helper from 0 to the number of steps, right? So this will be, I'll just give you a DP formula. You can calculate it yourself. So the DP formula will be at the 0th index, and you need to return the number of steps. So this will be the DP solution, and DP at I comma j will be equal to, so DP at I and j minus 1 plus DP at I and DP at I plus 1 and j minus 1, and also DP at I minus 1 and j minus 1. So base case will be, I mean, if you are at a 0th step and 0th index, so that is one possibility, right? So this is the base case, and with using this, you can fill this. So try it yourself, this solution, but also this memorization solution also should get accepted, should be okay for in your interview also, because the both time complexity and test complexity are same. But yeah, try doing this solution also yourself. Yeah, thanks for watching. See you in the next video.